Hello, ladies and gentlemen. My name is Eric. I'm from Hytera Marketing and Solution Center. It's nice to meet you all. Welcome to this webinar on Hytera's fast deployment communication solutions for emergency rescue. Today, the webinar is divided into 3 parts. In first part, let's review some natural and man-made disasters that have occurred around the world. Then, analyze the communication challenges faced by the emergency response teams. In the second part, to present Hytera's emergency communication rescue solutions for different scenarios, including city rescue and remote area rescue. And the third part is a case study, where we will share real-life cases involving Hytera communication equipment and solutions to demonstrate the technical feasibility and effectiveness of our solution. First part, let's discuss about challenges in emergency rescue. So, we talk about natural disaster first. Wenchuan earthquake was on May 2008. Its epicenter was located in Wenchuan County, Sichuan Province, and this earthquake measured 8.0 on the surface wave magnitude scale, and the earthquake intensity reaches 11 degrees, making it the most destructive, widespread, costly, and difficult to rescue earthquake in the history of China. Such a severe disaster disabled mobile phone communication, telephone communication, and even satellite communications, posing tremendous challenges for rescue teams. And it also causes numerous deaths, missing persons, injuries, and destroy a large number of infrastructure such as houses, schools, hospitals, bridges, and roads, with direct economic losses reaching 845 billion yuan. Next, the Typhoon Yagi making landfall in Hainan. Statistics shows that over 25,000 houses in Wenchang City were damaged, and nearly 1/3 of roads were blocked due to the fallen trees. 139 power lines were out of service. 792 communication base stations were damaged with an 82% power outage rate. And 8 out of 11 water plants ceased operations due to power outage, resulting in direct economic losses of 32.7 billion yuan. This kind of terrible natural disaster caused tremendous harm and loss to people, posing enormous challenges to communications. So it is crucial to respond quickly to rescue operations and establish communication channels. Besides the natural disaster, here are some man-made disasters. In 2001, September 11 attacks World Trade Center and the Pentagon. Nearly 3,000 people were killed, 6,000 people got hurt, and the firefighters, medical teams, and rescue team. And the loss of life for countless first responders and firefighters could have been prevented if police officers surveying the damage in helicopters could warn first responders. But unfortunately, they use different communication network and equipment that hinder communications. Then, here is a picture from 2004. A terrorist attack occurred at a train station in Madrid City. According to the subsequent statistics, this horrific attack ultimately resulted in 191 deaths and 1,800 injuries. At that time, many witnesses and victims attempted to call emergency service, but a sudden surge in call volume caused severe communication congestion, resulting in unable to connect and call interrupted situations. In this crisis, this tragedy vividly highlighted the critical importance of emergency communications during crisis. And finally, as seen in the 2011 riots in London sparked by the police shooting of Mark Dugan, which resulted in violence and chaos across the city, or the 2021 riots in South Africa triggered by the arrest of the former president Jacob Zuma, which led to widespread looting and destruction, reliable communication has become the cornerstone of the effective emergency response. All these incidents, like the natural disasters, clearly illustrate the importance of the emergency response communications. So, in the disasters described above, emergency communication face big and tough challenges, and the most serious ones are damaged network infrastructure, power outage, and blocked roads. When networks stop working, rescuers have a hard time sharing important information, and that makes rescue operations a mess. Power failures shut down communication base stations and switching centers, and backup power, which doesn't last long, can't keep things running for a long time. Blocked roads make it even worse because it is almost impossible to move important communication devices like portable base station through damaged roads and rough area. On top of that, trying to take care and replace battery during long power outage is really hard without electricity, showing how badly people need strong and reliable emergency communication solutions. So you may wonder who needs communication in disaster rescue. The rescuers on the front line depend on communication to talk to each other, send pictures and videos of the disaster area in real time so everyone knows what's going on, and have a reliable way to get orders from the command center. And the command team, which connects the on-site command center and the one at base, have to stay in touch with all of the rescue workers on the front line to make sure the whole rescue operations runs smoothly. What's more, the medical rescue teams need to maintain real-time emergency command and coordination, coordinate rescue efforts across multiple teams and regions, and connect with medical experts to provide remote support. In summary, during disaster rescue operations, effective communication is the key to success, especially during the crucial 72-hour period when saving lives, figuring how much damage there is, and protecting important buildings and facilities are the most important things to do. Then I will present Hytera's emergency communication rescue solutions for different scenarios, and it is divided into city rescue and remote area rescue. And let's talk about city rescue first. So, what kind of communication system is needed when a disaster strikes a city? The discussion will focus on two scenarios, the minor disaster and the major disaster. So, a minor disaster refers to a disaster whose impact is limited to a local area within a city, such as a single community or street, and whose intensity is relatively low, such as a small fire, localized heavy rainfall or flooding, or minor traffic accidents. And a major disaster refers to a disaster whose impact covers the core area of a city or multiple functional zones, such as an earthquake affecting the main city area, a large-scale terrorist attack, or extreme heavy rainfall flooding the city, and whose intensity exceeds conventional response capabilities. So, in the case of a minor disaster where the existing LTE network and PMR network infrastructure remain operational, we recommend a solution combining fixed networks and ad hoc networks. In the case of a major disaster where the basic LTE network and PMR network have been damaged, power is cut off, and roads are blocked, Hytera recommends using ad hoc networks. So, in city minor disaster, although infrastructure, networks, and power remain functional, challenges such as incomplete network coverage, poor device capability, and high-cost, low-efficiency temporary coverage solution affect effective response. To address this, it is recommended a hybrid approach, where trunking and poke technology provide seamless city coverage, while ad hoc equipment rapidly establish temporary connectivity in hard-to-reach areas like the underground or blind zones. And how to ensure real-time communication between on-site rescue teams and remote command centers, 4G and 5G networks. So, this strategy offers advantages. It can minimize redundant costs while using established trunking and poke network. Ad hoc devices deploy within 10 minutes to eliminate blind spots in underground or old districts, enhancing coverage efficiency. By using existing networks as a backbone and ad hoc solution as a supplement, this approach delivers reliable, cost-effective, and rapid response communication, significantly boosting efficiency in city minor disaster relief. To address city minor disaster, our primary strategy involves establishing a robust PMR network alongside the existing public 4G, 5G network, with a focus on seamless convergence and expandability. And for frontline emergency rescue teams, this infrastructure is complemented by portable dispatch center and ad hoc networks, paired with radio devices including POC, PMR, and dual-mode radios to ensure unified communication. This approach enables real-time command coordination, and the PMR network provides secure, low-latency trunking for professional teams, while 4G, 5G provides public bandwidth for data-intensive tasks. Portable dispatch centers act as mobile hubs, integrating ad hoc networks to extend coverage into signal blind spots, while multi-band radios eliminate protocol barriers, allowing teams to switch between POC for public network connectivity and PMR for dedicated trunking. This infrastructure empowers rapid, efficient response in city minor disaster. In major urban disaster, infrastructure, fixed network, and power supplies are completely destroyed. This blocks equipment deployment, and standard devices can't work in the harsh environment. So how do we keep communication alive? Here is a solution. When traditional networks fail, temporary network paired with drones become our lifeline. Drones flying above buildings, carrying ad hoc network devices that create a sky-based connection. This breaks through physical barrier, covers wide area, and keeps the network running. Rescue teams send live voice and video to portable command centers on the ground. Commanders use triple-screen computer to watch real-time footage, send resources like ambulance to the right spots, and check every team's GPS location, all to make quick, smart decisions. Satellite communication links the on-site to remote command center, so the experts far away can help too. Hytera's plan focuses on three key things. Fast setup, thus rescuers can deploy network in 10 minutes. Flexibility means adapting to any disaster, and offline operation means the device can work without power or fixed networks. This way, even in the worst disaster, rescuers can restore communication fast and coordinate all rescue efforts into organized action with simple top tech. When major urban disasters strike and infrastructure fails, these devices form our communication lifeline. Emergency rescue teams use self-sustained networks that operate without power, paired with drones carrying mini network hubs. Drones fly over to create sky-based coverage, while portable dispatch centers on the ground receive live feeds from teams. Satellites connect these hubs to the outside world, enabling calls for help, even when all a ground network are done. And the real command center relies on dispatch software to check every team's GPS location, allocate resources like ambulance, and monitor live video from the field. And finally, Hytera provides several types of terminals for our rescuers to choose. POC radios use any available cellular signal for quick calls. PMR radios work on dedicated emergency channels for secure communication. Dual-mode radios switch between POC and PMR to adapt to changing network conditions. IS radios ensure the security of the rescue teams. Body-worn cameras stream live video to command centers, helping commanders see exactly what teams face. So, I just finished introducing city rescue communications. How about the remote area rescue? Then, let's discuss what kind of communication solutions Hytera can provide to support rescue efforts in remote areas when disasters occur. When disasters strike remote areas, we recommend an emergency communication system combining ad hoc networks, integrated base station, and emergency communication vehicle. The emergency communication vehicle acts as a mobile hub, reaching powerless roadblock zones to set up temporary networks with building equipment. Ad hoc networks form self-sustained links between rescuers' radios and devices, working seamless in mountains or forests without fixed networks. IBS serves as a bridge, providing real-time network for people in the field. This quickly builds a reliable communication network in remote area rescue scenarios, keeping rescue teams connected and enabling vital emergency response. In remote area disaster, key challenges exist. Rescuers must arrive fast with equipment. Victims, rescuers have no network coverage. Large area, complex terrain blocks signals, and on-site teams lose contact with command centers. Our solution, ad hoc networks and IBS, an emergency communication vehicle. First, the emergency communication vehicle rushes teams and devices to the scene. It's a mobile hub with power and communications gear, ready to set up temporary networks. Then, rescuers carry ad hoc devices into the field. This forms a digital relay network, no base station needed. They let teams talk and send videos across mountains or forests, even where signals normally die. Meanwhile, drones fly IBS into the air. IBS acts as like a satellite bridge, giving both victims and rescuers internet access. This breaks through terrain barriers, so phones can connect again. Finally, the on-site command center uses HF radios or satellites to link with remote commanders. This lets them send live video, share maps, and get orders, no matter how far away the base station is. Together, this provides a fast, top solution for remote disasters, getting communication up quickly, even when everything else fails. In remote area disaster, these devices form our solution. Emergency rescue teams use self-sustained networks and deployable systems that set up quickly. These networks let teams talk and share data across mountains or forests without relying on fixed infrastructure. And the on-site command center relies on an emergency communication vehicle, a mobile hub with power and communications gear, rushing to the scene to build temporary network. Alongside it, a portable dispatch center processes live data from teams. To connect with outside world, the center uses HF radio and satellites, which transfer signals through terrain barrier to reach remote bases. Back at the real command center, dispatch software checks every team's GPS, manages resources, and displays live video from the field. HF radios and satellites here maintain real-time links. Together, these devices create a top, flexible system. Self-sustained networks view signal dead zones, and the emergency vehicle delivers rapid setup. Portable dispatch center coordinate on-site, and HF radios, satellites bridge the distance to experts. And also, Hytera provides various terminals. All over, Hytera's solutions for city and remote area rescue are built on the strategy of network and devices designed to adapt to different disaster scenarios. For daily operations and minor emergencies, our big networks like PMR and POC network serve as the backbone, enabling seamless daily communication and coordination for teams, facilitating real-time data transmission and interaction, supporting critical public services like ambulance dispatch and police operations, ensuring commercial operations run smoothly, and acting as reliable emergency backup infrastructure when primary networks face disruption. Meanwhile, when major disasters strike and traditional networks fail, our ad hoc and deployable network, let's say small networks, take over. They can quickly rebuild emergency communication, enabling technical on-site operations, connecting remote areas cut off from signals, providing flexible coverage for sudden events like emergency camps, and penetrating underground or indoor blind spots where standard signals can't reach, all without relying on fixed infrastructure. Complementing these networks, our common devices offer solutions to meet diverse customer needs. Portable radios that are lightweight and durable for frontline use, IS radios that add security to sensitive communications, poke radios that switch between cellular and backup modes for consistent connectivity, satellites that bridge long distance to link remote teams with command centers, and emergency communication vehicles that serve as mobile hubs, rushing to site with power and equipment to deploy networks instantly. Together, this integrated approach ensures that whether you are managing routine missions, responding to city disasters, or operating in remote regions, Hytera's solution delivers the reliability, flexibility, and speed needed to keep communication alive and save lives. Because in any disaster, every second of connectedness counts. Okay, above are Hytera's overall solutions for emergency rescue. I suppose that you may be interested in the device and terminals. So next part, we can deeply discuss some features of our narrowband voice ad hoc products. Here, you can see two handheld radios are not that far away, like 3 or 4 kilometers. They can communicate directly. However, when a distance exceeds communication range between the two handheld radios, then Hytera introduced the ad hoc repeaters, which act as a repeater between the two handheld radios. Therefore, the ad hoc devices serve as a repeater, and the handheld radios do not need to switch channels. They remain on their original channels. This device joins in and establishes voice communication. When the distance is even longer, when we deploy another ad hoc product nodes, once you power on them, the two ad hoc repeaters can automatically and wirelessly connect with each other. These devices do not require external links like the fiber or microwave and connect it wirelessly. So that is why they call ad hoc repeater. Finally, our ad hoc repeater can establish voice communication with these third-party handheld radios. If our customers' handheld radios are over the DMR Tier 2 open standard, our narrowband ad hoc repeater can communicate with these terminals. Next, our ad hoc repeater supports two concurrent group calls, as there are two passes in one device. As shown here, a narrowband ad hoc network has been established between the three units. Members of Group 1 can use these narrowband ad hoc networks to communicate with members of Group 1 at a remote location. Members of Group 2 can use this narrowband ad hoc network to communicate with members of Group 2 at a remote location. And there is no interference between these two groups of communications. And the two passes, each pass requires 12.5 kHz frequency. Via palm microphone, you can choose the frequency or group to stay and scan. Those two passes of ad hoc repeater can be set as one pass to work locally and the other pass to form a large network with other repeaters. Additionally, it's often asked whether it supports encryption. The answer is yes. AES 256-bit advanced encryption for end-to-end encryption is supported. Next, let's talk about real-time monitoring via positioning. Narrowband voice ad hoc repeater form a communication network, enabling connected handheld radios to send GPS, BeiDou, GLONASS location data to command centers. Each ad hoc repeater uploads GPS information up to 120 times per minute. With programmable intervals, location data transmit with voice, so people in the command center can see every ad hoc repeater and the radio's position in real time. Very ideal for dynamic rescue dispatching. Then, besides the narrowband ad hoc repeater for voice, we will introduce the broadband mesh solution for on-site video capture. During emergency rescue operations in remote areas, rescuers deploy the emergency communication rescue vehicles to the disaster site and activate the on-site command center and mount the mesh devices on the vehicle, with frontline rescue personnel carrying mesh devices and some using handheld mesh devices. This enables the entire disaster site situation to be transmitted via video, allowing the on-site command center to monitor what is happening at the rescue site, and the on-site command center communicates with the remote headquarters via satellites or fixed networks. Now, let's turn to real-world applications of Hytera's emergency rescue solutions. In the simulated typhoon-induced triple breakdown scenarios, our devices quickly restore communication, ensuring seamless data flow between the command center and rescue teams. This is just one example. Hytera have also successfully aided earthquake relief in China and disaster response in international events, demonstrating our solutions' reliability and efficiency. As you can see from the image, when a disaster strikes, chaos ensues. Power collapse, communication networks fail, severing lifeline connection, transportation routes are disrupted, blocking emergency access. This triple collapse, power outage, communication disruption, and road blockage creates a dangerous environment, isolating affected communities and urgently requiring resilient solutions. During the Jiuzhaigou earthquake, communication infrastructure crumbled, leaving rescuers in the dark, and rescuers strapped on Hytera's voice ad hoc devices, instantly creating a self-sustained communication network amidst the chaos. These devices enables seamless voice communication between the command center and frontline teams, and the rescue staff could issue real-time instructions, guiding teams through collapsed buildings and hazardous terrain. With reliable voice link, rescuers coordinate search efforts, share critical updates, and ensure no life was left behind. Hytera's solution bridges the communication gap, proving invaluable in this challenging rescue mission. During the rescue operations in the flooded Shijinjiang Tunnel in Zhuhai, China, our communication solutions were put to the ultimate test. Rescue teams utilized a range of devices, including multi-mode advanced radios, dome cameras, and DV cameras, to ensure 24 hours video streamlining for 8 consecutive days. These devices capture crystal clear images, regardless of the time of the day. As rescuers advanced deeper into the tunnel, so did our video equipment, maintaining a real-time visual feedback to the command center. This seamless video transmission was crucial for guiding the rescue efforts, ensuring every step was monitored and coordinated effectively. In the recent typhoon hit subway rescue, communication was a lifeline. A ground-based command center took charge, while underground mesh devices form a network to stream live video, and narrowband devices ensure clear voice communication. And entrance devices was crucial. They link devices on each floor, acting as bridges between levels, and the broadband ad hoc network transfer video, and the narrowband devices do voice communication, giving the ground command center a real-time view of the flooded subway, tunnel, parking, and roads. Once informed, the on-site command center reported updates to the remote command center via 3G, 4G, or 5G, or satellite links, enabling coordinated and effective rescue operations. In short, Hytera's emergency rescue rapid deployment communication solution redefines the possibility of crisis response. Our self-sufficient network, multifunctional terminals, and rapid deployment equipment ensure seamless communication even in the most extreme triple failure scenarios. Whether it is city rescue, remote area rescue, or guiding remote operations, our solution provides reliability and efficiency. So, thank you for joining us today's webinar. Please stay tuned for more updates on how Hytera are driving the future of emergency communications.